Good morning, class. Today we're going to discuss section 7.5, which is solving radical equations. We'll also jump into section 7.7, which are complex numbers. And then at the end, we're going to do section 7.6, which are applications of radicals. Okay? All right. First step is section 7.5. So 7.5, radical equations. Okay? All right, so a radical equation is the following. Let me give this example. Radical equation, here we go. The square root of 4x plus 1. Okay? Plus 1 equals x. This is a radical equation. It's an equation, look. It contains a radical. Okay. So what we're going to do with this radical equation is to solve this radical equation. The first step is we're going to isolate the radical. Step 1, isolate the radical. Okay. So let's bring this to the right. Get this by itself. Get this radical by itself. So we have the following. The square root of 4x plus 1 equals to, bring this to the right, x minus 1. That's your step number 1. Step number 2. If the radical has index of 2, if we have the square root, once your radical is isolated, square both sides. So once your radical is isolated, if the index is 2, square both sides. If the index is 3, cube both sides, and so on. So square both sides or cube both sides depending on the index. Okay. So here the index is 2 because it is the square root. So I'm going to square both sides. Okay. So let me rewrite it. The square root of 4x plus 1 equals x minus 1. And I'm going to square both sides. So square this side and square this side. Note, this is a binomial. When you square a binomial, you have to FOIL. Okay? This is a single radical. When you square the square root, the radical goes away. So this power is going to get rid of the square root when the square root is by itself. Okay? So this power gets rid of the square root when you square it, and we get what? 4x plus 1. This you have to FOIL. That is, let me show you once. Write it out. X minus 1 once, x minus 1 twice. And then you have to FOIL. So we get 4x plus 1 equals 2. Square this. X squared, right? That's first. Outer and inner. Outer is negative x. Inner is negative x. So we get negative 2x. That's outer plus inner. And then last, negative 1 times negative 1 is plus 1. Okay, so here's what happened. When you square the square root, hey, the radical goes away, okay? That's always gonna happen. Watch this. Watch. The square root of x, quantity squared. Watch this. This is the square root of x times the square root of x. Okay? Watch this. So the square root of x times the square root of x. Remember this property? The square root of a times the square root of b equals to the square root of ab. That's the product rule. So you multiply ab and you keep the radical. So you multiply x, so we get the square root of x squared. And what is the square root of x squared? Isn't that just x? So therefore, when you square the square root, the radical goes away. And that's how this radical went away. When I square the square root, it goes away. And there's the proof right there. Okay? All right. So, now we're going to solve. So step 3, solve. And step 4, check. So this is quadratic. Quadratic. Okay? I'm going to set it equal to 0 because it's quadratic. Bring this to the right. You see this 1? This 1 cancels this 1. Okay? So therefore, this happens. This one cancels that one. Okay? You see this 4x? I'm going to bring it to the right. So what do we get? We get 0 equals to x squared. What's negative 2x minus 4x? Negative 6x. Okay? So we have a quadratic equation. One side is 0. How do we solve? Factor the quadratic side. So 0 equals 2. Take out the greatest common factor, which is x. X times x minus 6. Okay? And now, by the power of the zero factor property, the first factor x equals 0, or the second factor x minus 6 equals 0, which means that x equals 0 or x equals to 6. Okay? Now we got to check our answer. We solved, and now we have to check our answers. Okay? Try x equals 0. Try x equals 0. X equals 0. Okay? Plug in 0 there and 0 there. What's 4 times 0? That's 0. What's 0 plus 1? That's 1. So when x equals 0, this one is going to be the square root of 1 plus 1 equals to 0. What is the square root of 1? 1. This is 1 plus 1 equals 0. Is that true or false? False. So x equals 0 is not a solution. It is what I call basura. Basura means trash. You guys know that, right? Basura. So x equals 0 is basura, trash. Let's check x equals 6. X equals 6. What's 4 times 6? 24. Plus 1. 25. So when you plug in 6, you get the square root of 25 plus this 1 equals to what? 6. What is the square root of 25? 5 plus 1 equals to 6. True or false? True. Hey. So x equals 0 is basura, and x equals 6 is an answer. So what's the solution to this? Solution. Six. That's the solution. Okay? All right. Very good. So these are the 4 steps that we're going to take. Okay? Let's do another one. Here's another one. Here's one more. Try this one. Okay. Try the square root of x plus the square root of x plus 3 equals 3. Okay. All right. So we're going to isolate the radical. Problem here is that we have 2 radicals. We have this radical and we have this one. No problem. Let's isolate one of them. Okay? In theory, it doesn't matter which one. But it makes it easier if we isolate the more complicated radical. Okay? So this one right here. This one is more complicated than that one. So I'm going to isolate one radical. This one. In theory, it does not matter which one you isolate. My advice is always isolate the more complicated one. If they're both equally complicated, then it doesn't matter. Okay. So to isolate this radical, I'm going to bring this to my right. Okay. So watch this. Bring this to my right. The square root of x plus 3 equals to 3 minus the square root of x. Okay? So this radical is now by itself. Now if I square this radical is going to go away. This radical is not by itself. No, it isn't. This radical belongs to a binomial. Look, 3 minus the square root of x. That's a binomial. This radical is not by itself. Okay? Okay, so now I'm going to square both sides. Square both sides. Class. Square this side. Square this side. Because this radical is not by itself, this radical is not going to go away. This radical does go away. Okay, when I square this square root, what do you get? X plus 3. When I square this binomial, I have to FOIL. And that's why this radical is not going to go away. I'm going to show you once, okay? So watch this. You see this? I'm going to write it twice according to this power. 3 minus the square root of x once. 3 minus the square root of x twice. There you go. Okay? This radical went away because I squared the square root. Now I'm going to FOIL. So this x plus 3, let me FOIL this. First, 3 times 3, 9. Outer, what is 3 times negative square root of x? Isn't that negative 3 the square root of x? That's outer. How about inner? What's negative square root of x times 3? Isn't that negative 3 the square root of x? How about last? What is the negative square root of x times the negative square root of x? What's a negative times a negative? Plus. And what is the square root of x times the square root of x? Remember that rule? Remember this rule? The square root of a times the square root of b equals the square root of ab. So when you multiply the negative square root of x times negative square root of x is positive, and the square root of x times the square root of x is the square root of x squared. And the square root of x squared is x. Okay, that's FOIL. All right, lucky for us, this, oh, by the way, look, the radical didn't go away. I'm gonna simplify. Let me simplify first, okay? So we get x plus 3 equals 2, 9, collect those two, combine those two, minus 6, the square root of x, plus x. There you go, you see? Now, wait a minute. Now I'm gonna solve. Oh, by the way, you see this radical? It did not go away. This radical came from squaring this binomial with a radical. The radical did not go away. That's because this radical is not by itself. This radical is part of a binomial. That's why it didn't go away. So whenever you have a radical, which is part of a binomial, and you raise it to a power, the radical is not gonna go away. Okay, let's solve. So this, oh, now I have to isolate this radical, okay? To isolate this radical, I'm gonna have to get it by itself, but I notice right away that this x cancels that one. Yes, they do. I'm trying to get this by itself, okay? Trying to get this square root of x by itself. So subtract 9 from both sides. What is 3 minus 9? Negative 6. That's negative 6 equals to negative 6, the square root of x. Okay? You see, this square root of x is not in a binomial. It isn't. The square root of x is a monomial. Look, it's negative 6 times the square root of x. At this point, you can square both sides. Okay, because this square root of x is basically, theoretically, isolated. Now, if you want to continue to isolate it, divide both sides by negative 6. You can do that, okay? So divide this by negative 6 and divide this by negative 6. When you divide this by negative 6, you get 1. When you divide this by negative 6, you get the square root of x. But theoretically, I can square both sides here. Yes, I can, and I'll get the right answer. Okay? Now, how do I solve for the x now? Well, let's square both sides again. Square this. What is the square root of x? Square. Square. This is 1, and this is x. Now remember, this may be basura. Is it basura? What I write? Is this basura? It's a question. We don't know until we check. So let's check. Check it. Okay. Plug it in there. Plug in 1 there. What is the square root of 1? The square root of 1. 1 plus 3. The square root of 4 equals 3. Okay. What is square root of 1? 1. What is the square root of 4? 2. Is that equal to 3? Yes. True. The solution to this is 1. Solution? 1. There it is. Okay. All right. This is section 7.5. Okay? Go over it, okay? And then do your homework. Let me go through section 7.7 first. Maybe I should go through section 7.6. Let me go through section 7.6. Okay? All right. In section 7.6, good class, we have special right triangles. We have the 30, 60, 90 special right triangle. We also have the 45, 45, 90 special right triangle, okay? Let me start with the 30, 60, 90. So let's draw a triangle. So this section 7.6. 7.6. 7.6 is gonna be, 7.6 is geometric applications of radicals. Geometric applications of radicals. Okay? So we need the special right triangles. Special right triangles. There are two of them. First, it is the the 30 degrees, 60, and 90. That means 90. Okay? I'll just give you the rules, okay? This is what it says on page 643. But I'll just read it to you guys. It says, the length of the hypotenuse of a 30, 60, 90 triangle is twice as long as the length of the short leg. You see this 30? The side opposite, this is the short leg. Short leg. This must be the long leg. Long leg. This must be the hypotenuse. Hypotenuse. Okay. So, this is what they say. Let's call the short leg, let's call it A. Let's call the long leg, let's call it B. This is the long leg, we're gonna call it B, okay? Let me erase this, okay? Because you guys already know which one is the short leg and the long leg. I'm gonna call the short leg A. I'm gonna call the long leg B. I'm gonna call the hypotenuse C. And they're saying the length of the hypotenuse of a 30, 60, 90 triangle is twice as long as the length of the short leg. The length of the hypotenuse C is twice A. That's what they're saying. Okay? And here's another one. The length of the long leg of a 30, 60, 90 triangle is the square root of 3 times the length of the short leg. The length of the long leg, B, is the square root of 3 times the length of the small leg. Okay? We need that. Yes, we do. The length of the long leg of a 30, 60, 90 is the square root of 3 times the length of the short leg. Okay? All right. So look at this. Once we have this information, we can figure out any 30, 60, 90 right triangle. Watch this. So let me give you this one. Here is a triangle. Okay, there you go. And it's 30, 30, 60, 90. This is 60. Okay? 30, 60, 90. Because this is 30, this must be the short leg. This must be the long leg. And you see the side opposite the 90-degree angle? That's the hypotenuse. This is the hypotenuse because it's the opposite this square. Okay? 90 degrees. Okay? All right. I don't know. Let's make this 3 inches. Watch this. Let's make this 3 inches. Let's make the long leg 3 inches. And the question is, can you find the short leg and the hypotenuse? Yes, you can with this. Okay? You see, the long leg is 3 inches. This is the long leg. Once you plug in 3 inches here, you'll be able to get the short leg. Once you're able to get the short leg, you're able to get the hypotenuse because the hypotenuse is twice the short leg. So let's get the short leg first. Let's plug in 3 inches for B. Okay? Plug it in there. 3 inches equals the square root of 3 times A. Okay? How do you solve for A? Divide both sides by the square root of 3. Yes. Divide this by the square root of 3. I can show you it, okay? Divide this by the square root of 3. Divide this by the square root of 3. The square root of 3's cancel each other. And so therefore, A equals to 3 divided by the square root of 3. Now, in the past we said that whenever there was a radical in the denominator, we had to get rid of the radical. Okay, we can do that. How do I get rid of this radical in the denominator? Rationalize the denominator. Multiply this by the square root of 3. And multiply this by the square root of 3. Okay? This is beautiful. Now. All right. All right. So, I'm going to simplify this. A equals 2. This is 3. The square root of 3 divided by, and this is the square root of 3 times the square root of 3, which is the square root of 9. And the square root of 9, what is the square root of 9? 3. Okay. So what is A? The square root of 3. Okay. Wow. So the long side, the long leg is 3 inches. The short leg is the square root of 3 inches, which is 1 point something. I forgot what, I think it was 1.7 maybe. I'll just leave it like that. This is the square root of 3 inches. And now the hypotenuse is twice that. Look, hypotenuse is twice the small leg. So therefore the hypotenuse is 2 times the square root of 3 inches. And so now we got this. We figured out the size of this special 30, 60, 90 right triangle. Okay. Here's another one. Here's one more. Watch this. Okay. Let's make this 90. Let's make this 30. And let us make this 60. Okay. And obviously, this must be the short leg. This must be the long leg. This must be the hypotenuse. Okay? So, I don't know. What is this length, do you think? What should I give? I gotta give you something, okay? So let me give you the hypotenuse. How long do you think the hypotenuse is? I don't know. 18 inches? 18 inches? Sure. Let's make this 18 inches. Okay? So my question is, if the hypotenuse is 18 inches, what is the short leg and the long leg? Well, let's use these equations. The hypotenuse is twice the small leg. So this is twice the small leg. So if this is 18, that means that the small leg is 9 because it's twice the small leg. So this must be 9 inches. Okay. The long leg is the square root of 3 times the small leg. Okay. The long leg, here's the long leg, is the square root of 3 times what? The small leg, which is 9 inches. And you got it. You see? Okay. So this is the 30, 60, 90. Okay. Let me give you 45, 45, 90 right triangle. Okay, so these equations you can use for the 30, 60, 90 right triangle. Gotta go. Okay. How about the 45, 45, 90? Let's do like this. 45 degrees, 45 degrees, 90. Okay? Because this is 90, this must be the hypotenuse. This must be a leg, this must be a leg, and because the angles are equal, the legs are equal. Okay? Because the angles are equal, that means the legs are equal. Okay? We are gonna call that triangle an isosceles triangle. Okay? So, this is a leg. Let me call this leg A. Let me call this leg B. And let me call the hypotenuse C. Because the angles are equal of the opposite sides, that means the legs are equal. So A equals B. Mm-hmm. Okay. Now, in an isosceles right triangle, in a 45, 45, 90 right triangle, the length of the hypotenuse is the square root of 2 times the length of the leg. The length of the hypotenuse, C, is the square root of 2 times the length of the leg. Because A equals B, doesn't matter which leg. I'm going to say A. There you go. This is what you need to remember for a 45, 45, 90. They call it isosceles triangle. Okay? All right. Watch this. Suppose I draw a very small right triangle. Very small isosceles right triangle. There you go. This is 90. I don't know if you can see it. And this is 45 right here. That's 45. Okay, I'm going to write 45 right there. 45 degrees there. And that must be 45 also. This must be 45. Okay. All right. This must be the hypotenuse. This must be C. Guess what? Oh, I better give you a size so that we can figure out the other size, okay? Let me give you this side. Suppose this side, it looks like, I don't know, 1.5 inches. 1.5 inches. Okay? Because this is a 45, 45, 90 isosceles triangle. The legs are equal. So if that's a leg and that's 1.5 inches, this must be also 1.5 inches. So this is given, and so therefore this is 1.5. How do we get C? Well, C we can get from this property right here, this equation. C is the square root of 2 times A. So C equals the square root of 2 times either A or B, doesn't matter, 1.5. Okay? If you take your calculator and you take the square root of 2 times 1.5, you'll get a decimal. And that's your answer. Okay? So that's what C is. I don't have my calculator with me. Okay? You guys can do that at home. Okay? All right. So that's the first example. Here's another example. Now let's draw this big one. How about this big one? Note that if I say this is 45, that must be 45. I don't have to give you that one. Remember that, okay? All right, because this is 90, this must be C. And because this 45, this must be A, and that must be B, and that's 45. A and B are equal, okay? Once you know that this 45, then you can write yourself 45 there. Okay. What if we say to you guys, C is, I don't know, let me see, 1 foot, 2 feet, what do we say, 2.25. C is 2 point, let's make it simple, okay? Let's say 2.5. 2.5 feet. Okay. Well, our job is to find A and B, and they are equal. Once you find A, you have also found B. Okay, well, they gave us C. I can find A by plugging C here. C is 2.5. C is 2.5 feet equals the square root of 2 times A. Divide both sides by the square root of 2 so that A equals to 2.5 divided by the square root of 2. At this point, you can use your calculator and find out what it is, okay? Find out what it is to, as a decimal, okay? If you want to take it further, get rid of this radical in the denominator. Multiply top and bottom by the square root of 2, the square root of 2. Okay? So that A is going to be the square root 2.5 times the square root of 2. And this is the square root of 2 times the square root of 2, which is the square root of 4, which is 2. Okay? So watch this. So A equals to, how many times does 2 goes into 2.5? 1.25. The square root of 2. And now you can use your calculator and find out what that is. So this is in feet now. It's in feet. So A is 1.25 times the square root of 2 feet. And B is also 1.25 times the square root of 2 feet. Okay? And we got it. Okay. All right. That takes care of, what does that take care of? This takes care of what? Of section 7.6. Let us do section 7.7. Section 7.7, good class. Section 7.7. In section 7.7, we are now, section 7.7, 7.7, okay? What is section 7.7, good class? It is complex numbers. Complex. numbers. Okay? All right. First of all, let me give you the definition of a complex number. Okay? What is a complex number? A plus BI is a complex number. Okay? Where A is the real part, B is the imaginary part, and I squared equals -1. Where A is the real part, B is the, let me go here, imaginary part. And I square equals to -1. Okay? All right. Don't forget this. I squared is -1. Okay? So let's make up a few complex numbers, okay? 3 minus 2i. What is A? A is 3. What is B? B is the imaginary part, -2. This negative goes with it, okay? And don't forget, I squared equals -1. So that's the first one. Here's another one. Six plus 5i. What is A? For this one, A equals 6, B equals to 5. All right. Okay. We can take complex numbers and we can add them, we can divide them, we can subtract them, we can multiply them. We can do all 4 operations with complex numbers. Okay? Yes, we can. And that is what I'm going to do right now. Okay? So let's take these 2 complex numbers. These are the imaginary part and the real part. Okay? First, let's take this number. Let's take 3 minus 2i and add it to 6 plus 5i. Okay? Then let's take 3 minus 2i minus 6 plus 5i. Note, I am taking the complex number. The first is I am doing the first operation, addition. This is addition of complex numbers. Addition. This is subtraction. Okay, multiplication. We can do multiplication too. Okay, we can do multiplication. 3 minus 2i times 6 plus 5i. This is multiplication. And we can also do division. 3 minus 2i divided by 6 plus 5i. Okay? This is division. All right? I'll erase this. Okay? Look. For the first one, addition. All you have to do is combine like terms. What's 3 plus 6? So when you add, what do you get? I'm going to write it right there. What's 3 plus 6? 9. What's negative 2i plus 5i? Plus 3i. So when you add these complex numbers, you get a complex number right there. Look. Where the real part is 9, the imaginary part is 3. Next, how about this one? Subtract. Let me do subtraction here, okay? Don't forget, when you subtract this negative, it's distributed. So what's 3 minus 6? That's negative 3. Don't forget, this is distributed. So what's negative 2i minus 5i? There you go. Okay. 3 minus 6 is negative 3. Negative 2i minus 5i is negative 7i. Look, what is a here? A is negative 3. What is b there? B is negative 7. What is a there? A is 9. What is b? B is 3. Okay? Let's do those two. I'm going to need room for those two. No problem. Let me do it here. 3 minus 2i times 6 plus 5i. Let's FOIL. FOIL. First, outer, inner, last. First, outer, inner, last. Okay? First, what's 3 times 6? 18. Outer, what's 3 times 5i? Plus 15i. That's outer. Inner, what's negative 2i times 6? Negative 12i. Negative 2i times 6 is negative 12i. Last, what's negative 2i times 5i? Minus 10i squared. Okay? Combine. Combine like terms. So this is 18. And what's 59 minus 12i? Plus 3i minus 10. And remember what we said? Remember we said that I squared is negative 1. Well, this I squared is negative 1. And now, so negative 10 times negative 1 is positive 10. So what's 18 plus 10? 28 plus 3i. Hey, that's what this is. When you multiply those two, what do you get? In multiplication, you get 28 plus 3i. And what is a here? A is 28. And what is b? B is 3. Okay, nice. All right. This is section 7.7, complex numbers. Let's do the last operation right there, look. The last operation, I'm gonna have to do it here. Gotta erase this, okay? Because I'm running out of room. Erase, okay? All right, excellent. So now, let me take 3 minus 2i divided by 6 plus 5i. Okay? When you divide complex numbers, you must multiply top and bottom by the conjugate of the denominator. Multiply numerator and denominator by the conjugate of denominator. There you go. Okay? Okay. What is the conjugate of this denominator? The conjugate of this, just change the sign. 6 minus 5i. Those two are conjugates. Gotta do the same thing to this one. 6 minus 5i. Okay. All right, and now go ahead and multiply. Well, at the bottom. In the bottom, you're gonna FOIL, but look, outer and inner cancels, okay? So what's 6 times 6? 36. Outer and inner cancels. Why? Because outer is negative 30i, inner is positive 30i, they cancel. How about last? 5i times negative 5i, negative 25i squared. Remember this I squared? It's over there, look. Okay. So this is first and this is last. Outer and inner cancels. And that always happens with conjugates. The top, they're not conjugates, so you have to FOIL. First, 3 times 6, 18. Outer, 3 times negative 5i. Negative 15i. Inner, negative 2i times 6. Negative 12i. Okay? Last, negative 2i times negative 5i. Plus 10i squared. Let me check again. 3 times 6 is 18. 3 times negative 5i is negative 15i. Negative 2i times 6 is negative 12i. Negative 2i times negative 5i is positive 10i squared. Okay. And we all know that I squared is negative 1. So I'm going to plug in negative 1 there and negative 1 there. And I'm going to combine those two together. Okay. So let's do that. So that's 18. When you combine those two, negative 27i. And then what's 10 times negative 1? Minus 10. Don't forget, this is negative 1. Negative 1 times 10 is negative 10. That's 36 in the denominator. And what's negative 1 times negative 25? Plus 25. Don't forget, this is negative 1. All right, last. What's 18 minus 10? 8 minus 27. Whoa. I. Divided by what? Is that 61? 61. All right. Okay, let's express this as a complex number. As a complex number. It's going to go right here. The answer to this is going to be, as a complex number, 8 over 61. It's coming from there. Minus 27 over 61i. Okay? And what is A? A is 8 over 61. And what is B? B is negative 27 over 61. All right, good class? And this is section 7-7, okay? Complex numbers, all right? And this completes the section, and this also completes the chapter, okay? Do your homework. I'll see you soon. Okay, bye.